We are going to study a little bit about structure, strength, properties, strain measuring devices, performance, and production. So this is the topic that we are going to study today. And basically, what everybody knows is very important for engineering material, and we can have alloys that are the result of combination of two types of metals. We have the ferrous and the non-ferrous metals. Ferrous major constituent is iron, and the non-ferrous major constituent is not iron. Here's some definition regarding that. I don't care much about it. And here we have some of the most important types of iron that we have: steel, wrought iron, cast iron. In general, the amount of carbon that these materials have is the most important factor. Depending on the amount of carbon is when you are going to decide what is the type of metal that you have, ferrous metal that you have. And another types of non-ferrous metals like copper, nickel, aluminum, magnesium, beryllium, and lead. What type of metals are you using in your project?
A lot of steel.
A lot of steel. What type of steel? What are the size numbers?
Well, I mean, if you talk about rebar, you guys
Exactly.
You know, we used a lot of anywhere from about 16 bars, but you know, the bridge structures and whatnot, there's 22s, 24s, ridiculous amount of steel. And then you've got all the structural beams for the.
Very good. Very good. Any other with experience with metals? Who has experience with metals? Robert?
Took a metal shop class in middle school.
Yeah, what about Lizzie?
No, not really.
No? Sadie? Donald McMurtry?
He was my TA.
Who's that?
I was. Rebar, that's about it. From number age 6 to 12, that's about it.
Rachel?
So we did in construction materials lab.
Okay, very good. Okay. So you're going to work a lot with that, so don't worry about it. Structure of metals. We are talking about a crystalline structure, and I'm going to ask this in the test. So keep that in mind. So we have some periodic arrays over large atomic distance. We are going to determine what is a unit cell. This is a unit cell. It's a small group of atoms form a repetitive pattern. This is a unit cell, and those patterns are referred as unit cell. This is a unit cell. This is a type, and this is another type. And we have some face-centered cubic, where you have the atoms located at each of the corners and the center of all of the cube faces. This is the only thing that I want you to remember about that, and this is an example. So it's very simple. We have body-centered cubic, BCC. In this case, the atoms are located at each of the corners. A single atom is at the cube center. So this is the body-centered cubic, BCC. And this is another example of that. And finally, we have hexagonal closed packet, this type of array. I don't care much about it, so don't be scared about it. This is a very important thing, and we are going to calculate that. Atomic packing factor, APF. It is the volume of atoms in the unit cell divided by the total volume of the cell. What is unit cell, Christine? Mr. Mark Zucker? Unit cell?
I think I might pass it to Tiffany.
Tanaya, how you llame?
Repetitive structure,
Pattern.
same thing.
Exactly, this is a unit cell. So the atomic packing factor is related with the unit cell. So it's basically the volume of atoms in the unit cell divided by the total volume of the cell. And we need a little bit the concept of volume of a sphere that you already know what it is. So we're going to find the atomic, yes.
Is that going to be on the test?
I'm not sure. Maybe the calculation, yes. The calculation, yes. All the other things before, no. I don't care about body center and all those things. But yes, maybe this calculation, yes. Okay, so now we have, for example, if we have two atoms, and we know that the volume of the sphere is this one, we can determine the volume of atoms in the sphere, in the unit cell. So it's 2 times, because we have 2 atoms, the volume. So this is the volume. And you have the diagonal of the cube here, and you have the volume of the cube. This is the volume of the cube. This is just mathematics. You already studied this maybe in high school or elementary school. So you have the volume of the cube and you have the volume of the atom. So we have to divide one by the other. So the APF is the volume of the unit cell divided by the unit of the volume of the atom. So basically 0.68. What is very important here and can be in a questions on false or true or multiple choice. What is the meaning of this 0.68%? Is that the 68% of the unit cell is occupied by atoms, whereas 32% is empty space. This is the APA. So if I am telling you that the APA is 70%, let's say not 70, let's say 50%, what is the meaning of that, Alisa?
How many unit cells there are in the total?
Exactly. So 50% is what?
There's 50% of
Atoms. Exactly. This is the meaning of that. Everybody agree with that? Yes?
Why does it matter? It just tells you a definition.
Well, for our point of view, civil engineers, nothing.
Yeah.
For chemists and all those guys, a lot.
Okay.
Material science people, a lot. Civil engineers, nothing. We care about what?
Strain.
Well, money, yes, money, what else? Stress, strain, modulus, deformation. But we have to study that. There is I think 1 or 2 classes about the steel design here that you can take to understand how to design it. But for this class, it's very basic. This is another example that you can scratch because I'm not going to tell you about it. And this also up to here, I don't care much. Strength. We have various tests that we can do. There are various tests that we can do. Tension, strength, torsion, impact, bending, fatigue, and hardness. What is tension? Right? What is a tension and strength test? Listen.
Pull it apart.
What?
Pull it apart.
Exactly. This is tension. This is a basic concept of the material science of our field. Torsion. What is torsion? Tanaya?
Twisting.
Twisting. Very good. What is impact? Donald McMurtry.
Shearing or like when it splits.
Hit. Impact. Is important to study impact or not?
Yeah.
Why?
Darkness.
Why is important?